This is the second video discussing the Fast Spectral Loss Measurement Engine. During the course of this video, we'll start the software, we'll perform a zero of all the power meter channels, we'll run a reference sweep, and then finally connect up a device and analyze the data using the DWDM analysis. The first step, once the Fast Spectral Loss Engine is open, is to run the configuration wizard. We can access this from the File pull-down menu and select Run Configuration Wizard. This is going to work and locate all the instruments that are available to make measurements with, and it'll find instruments over GPIB and LAN and also USB. And in this case, since I only have instruments connected over USB and GPIB, I'm only going to select those two interfaces. You can see it finds the multi-port power meter over USB, and it also finds the tunable laser over GPIB. After all the instruments have been detected, we can click Finish and then start the process of making a measurement. The first step is to define the measurement parameters we'd like to use. In this case, I'm going to make a measurement from 1510 nanometers all the way out to 1590 nanometers. I'll use a 100 nanometer per second sweep rate, although the laser I'm using, the 81960A, is capable of working at 200 nanometers a second. Another unique characteristic of the 81960A is that we can perform a two-way measurement. So it's a bidirectional sweep where it grabs data as the wavelength increases and also as the wavelength decreases, and I'll keep the default power range of plus 10 dBm. After the measurement parameters have been defined, we can zero the power meters and also perform a reference sweep by selecting the port reference configuration button shown here. The first step is to zero all the channels of the power meter, and I've already covered the input, so I can select zero channels 1 through 4, and it goes out to initiate the zeroing. The process of zeroing takes about 15 to 20 seconds per channel, but it ensures that all dark offsets are removed from the power meter channels. The next step is to perform a reference measurement for each channel that we're using. So I've got an optical patch cable connected directly from the tunable laser to the port 1 power meter input. I can select that I'd like to have a new reference performed, and it goes out and performs a reference measurement. I've also completed the reference measurements on channels 2, 3, and 4, and you'll see each reference has a time and date associated with it. So now we're ready to actually connect up a device and make measurements. So let me take a minute to connect up the device, and then we'll start making measurements here shortly. And so I have a device connected now. I'm looking at 3 channels, which are part of a 4-channel WDM mux. And in order to acquire data, I just need to either select Run Signal, which runs a sweep once, or Run Repeat. And I'll select Run Repeat right now to show you the benefit of the two-way bidirectional sweep. You can see not only do we acquire data during moving from the start wavelength to the stop wavelength, we're also able to acquire data as the wavelength is being reset back to the start wavelength. And so the benefit is that we're able to get data very quickly, and this is particularly useful if you're tuning a device and you need to get very fast update rates as you're tuning your device. The next step, once we've acquired data, would be to analyze the data, and there's an application license which is available called the DWDM analysis, which automatically finds, among other things, channel bandwidth, center wavelength, and other parameters that are of interest for each of the channels. And to activate this, we just need to right-click on the measurement and select DWDM analysis. And the default parameters are that it'll select any of the acquired data over the range that's being displayed, and we can select OK. And it automatically finds important parameters for each of the channels that are being displayed without requiring the user to go in and manually try and locate each of these parameters. And so the last feature that might be of interest is to export the data. So we're able to save the data as an OMR file and recall it back into the Fast Spectral Loss Engine client at a point in the future. We're also able to export the data that we see both to MATLAB and Excel. And so if I press Export to Excel, you'll see the Excel application is started, and there's a couple of different tabs in the workbook. There's an overview tab that talks about the start, the stop wavelength, and details of the setup. There's also the DWDM analysis tab that shows the results of the analysis for each of the channels. And then finally, we're able to look at the average insertion loss for all 3 channels. And so this is good for archiving and analyzing data offline. And so in summary, in this part of the video, we've talked about zeroing the power meters, performing a reference sweep, and also making measurements and analyzing the data. Thanks for reviewing the operations of the Fast Spectral Loss Measurement. If you have any questions, you can contact your local Agilent support team. We're here to help. In the Americas, you can reach the Technical Contact Center at 800-829-4444.